Here's our generic equations that we're going to work with. You'll notice the highlighted purple A is the amplitude change that you saw last class. The highlighted yellow B is the period changes that we saw last class. So those two highlighted pieces are the parts that are going to change the shape and size. The minus H is the horizontal phase shift. It's the opposite piece. So when I say minus H, it's actually going to the right, but plus H is going to the left. The plus K at the end is the vertical translation or vertical shift. Plus K means up K, minus K means down.
Example here, we want to sketch 2 cycles of the graph, and we're going to graph both the parent function in blue and the translated graph in pink. State the period and the amplitude, and label any critical values on the x-axis. So I started with labeling the first major points on the x-axis that we have been seeing. The parent graph is talking about the function without any addition subtraction in it. So in this question, our parent function is y equals sine theta. The plus 2 is our translation. Now y equals sine theta has no amplitude change, it has no period change. So the amplitude is going to be the usual 1, and the period is going to be 2 pi. So this is the perfect setup on our axis for that. So this is a sine curve. Sine curve starts at the origin. It ends at 2 pi on the axis, and in the middle it is on the axis as well. Sine goes up to a max first at the first quarter and down to a min at the third quarter. So here is my sine graph. It says to do at least 2 cycles, so there's a second cycle. We could also go negative if you wanted to. Now, the translated graph is asking us to go up 2. Okay, so I'm going to take each of these points and simply move them up 2 spots. It's not 2, up 2 spots. And you start to see that pattern arising. So it's not changing the period, it's not changing the amplitude, all it's doing is moving the whole graph up 2. Parent graph in this case would be y equals cosine of x. Now remember, x and theta, they're both just being there to represent the angle, and both are perfectly acceptable. Parent graph is anything without the addition subtraction. So cosine x typically has a period of 2 pi. It has an amplitude of 1. Cosine x looks very similar to sine. Where sine starts at the origin, cosine starts at a maximum point and it ends at a maximum point. In the middle of the period, it's at a minimum, and at the quarter marker, it's going through the axis. So there's your cosine curve. If I go one to in the other direction here to the left, there's another cosine curve right there. I could go to the right as well. Now, the translation, notice that this translation is included inside parentheses. So this is asking me to go left, right, and because it's a minus, it's actually going to the right pi units. Now, looking at my graph, here's pi right there. Pi is actually 2 boxes. So I'm going to go 2 boxes to the right every point. And you'll start noticing the pattern as you do it. Kind of looks like a DNA thing there, a DNA double helix. There's your graph. It does keep going, but that would be our translated graph. This one has a little bit more to it. It has 2 translations. I see 2 different addition subtractions. My parent graph is y equals sine x, so amplitude is 1, period is 2 pi. This is good practice for those main graphs that you are seeing. Sine starts at the origin, goes through the middle on the axis, and ends at the period value on the axis. It goes high to a max, and then low to a minimum. There's my sine curve. I'm going to continue it over a little bit. Now, we have two different translations here. The first translation is this plus pi over 2. That's inside the parentheses, so it's a left-right, and it's opposite what we think. So we're going to go left pi over 2. And looking at my picture, pi over 2 is one box. Then we're going to go down 1. So I'm going to take every point. I'm going to go left pi over 2, so left one box, down one box. Left one, down one, left one, down. And we see a little bit of repeating in your points, which makes it a little bit more confusing sometimes to continue those points on. There's our graph. Okay, example 4. Now we're actually throwing in some amplitude and period changes here. So it's not just a horizontal translation and a vertical translation. So I'm going to go to my parent graph first. I'm going to eliminate any addition subtraction. So I'm going to keep the 2 and the pi over 2 involved, but I'm going to eliminate the plus 1 and minus 3 at first. Now, this one does have an amplitude and a period change. This 2 out in front is going to cause the amplitude to go from -2 to 2 versus -1 and 1. So for sure, we're going to want to label our axis. We're going to go up to -2 or down to -2 and up to 2. The period is also different. The period value is 2 pi over 2, and that's the same thing as 4. So I'm going to label my x-axis 1, 2, 3, 4. Now this is a cosine graph. So cosine starts with a maximum on the axis. So I'm going to start at 2. It ends with a maximum at the period value, and in the middle it has a minimum. It's going to go through the axis values at the quarter markers. So here's another chunk of this graph, another cycle or period of the graph. We could do one in the negative direction. We only need 2, but it's nice to see a bigger picture. So now this plus 1 inside the parentheses, that's going to be left 1 unit. That's 1 box. It's going to be down 3. So every point is going to go left 1, down 3, left 1, down 3, left 1, down 3. And you can quickly pick up the pattern. So there's 1, can continue another 1. It's not a zigzag, it is a curve. Mine's starting to look a little bit of a zigzag. But there's my new graph. Okay, this one is the last of these examples. We want to sketch our graph. I'm going to start with my parent function, y equals -2 sine 1/2 x. Again, I'm just taking out the addition subtraction. I'm going to start with amplitude. The amplitude is +2. Amplitude is always positive, it's a distance. So we're going to be definitely working 1, 2, 1, 2 here. So it's taller than it normally is. The period is 2 pi over 1/2, which is 4 pi. So I'm going to go out 4 pi, and then we would have pi, 2 pi, 3 pi. Sometimes just figuring out your axis is the hardest piece. So this is a sine curve. Sine curve starts at the origin, ends at the period value on the axis. It goes through the axis in the middle. Normally sine goes up to a max in the first quarter, but because the 2 is negative, it's going to go down to a minimum of 2, up to a maximum of 2. So there's my first curve. I might just leave it there and then we'll translate from here. We want to translate this. We're going to go pi to the left. And looking at my boxes, that's 1 box. We want to go 2 down. So 1 box left, 2 boxes down. I feel like we did that a lot in these notes. Here's the first cycle of this graph, and then I can continue that pattern. As long as the final graph, I guess I would say, has at least 2 cycles, that's what I would be looking for here. So there's our graph. Our last question is writing an equation. So I put on our generic formats. We're going to write both a sine and a cosine curve here. The nice thing about sine and cosine curves is A, B, and K are all going to be the same value. The only thing that's going to be different between these two equations is, well, two things. One is A could be negative potentially, and the second thing is H. H will be different. So I'm going to start right here. If I just draw in this line, that line is at 2. This has been moved up 2. Normally, that is on the axis. That's what we call the midline. Now, look at what I did there. What I did was I just drew a line that goes through the middle of this graph vertically. So if I went from the maximum point to the minimum point, this line is in the middle. That's your K value. So I know in both of these equations, there's going to be a +2 at the end. So that's the first thing I do. From there, I'm able to find my amplitude as well. From the midline to a max, midline to a min, all of these are the amplitude value. And they each have a unit of, or a measurement of 1. So my A value is 1. Now, potentially that A value might be negative, but we'll deal with that in a minute. So I'll leave a little room in case we got to put a little negative in there. Okay, the next piece is the period. So the period is usually one of the trickier things for people to find. I'm going to use a darker color there because there's lots of different ways you can find the period. I'm going to go with one of the easier routes, which is I'm going to start at a max to the next max and just figure out how long is this distance. Now, one nice way to figure that out is use the fact that this is notability. Sometimes this is, so I just kind of move it over. Start at the axis. Hey, that's 2 pi. So if you're not quite sure, if what you struggle with is what's going on the axis and being able to read those values in pi, use the fact that this notability helps you do it. So the period here is 2 pi units. Now, if you went from min to min, you should get 2 pi. If you went from a max to a min, you'd have to double it to get that period value. Now, normally the period, 2 pi equals 2 pi over b in my equation, so b is clearly 1. So the period is not the b value, but you can use the period to find the b value. I'll rewrite these equations once we're done so that they aren't quite so colorful and they don't have all the pieces in it. Okay, now the h piece is what is tricky. It's usually the hardest piece. So I'm just gonna clean up some of this so that we can write on this a little bit easier. I don't want all of that gone. I actually just want this writing gone. Okay. So in purple, if I'm gonna do a sine curve, then normally these middle points that fall on the midline, those are usually at the origin. So they've been moved up to, that's the midline, but these spots are usually at the origin. So let's think about this value. This value is halfway between 0 and 1/2 pi. So it's at 1/2 or 1/4 pi. So negative pi over 4 right there. Normally, this would have been on the vertical axis. So it's been moved to the left. If it's been moved to the left, I'm going to do plus pi over 4. But that point is going down to a minimum. And usually sine curves go up to a maximum, so it's also been flipped. So one possible solution, there's lots of solutions here, but one possible sine equation is this. Perfectly acceptable right there. If I'm going to do a cosine graph, now I'm going to take out that purple so we can work with it. Now I'm going to look at either a max or minimum point. Cosine starts with a max or min on the vertical axis. So this minimum point is closest. It's also at pi over 4, but it has been moved to the right pi over 4. So I'm going to do minus pi over 4. And it's a minimum, so it's also negative. So another possible answer, this one in terms of cosine, is this. Now, this question has an infinite number of equations I could write. These are just simply two of them.